Thank you, Dilip. We're going to have the next speaker from Mayfield Robotics. Thank you.
Oh, there we go. Hi, my name is Kaijen Hsiao, and I'm the CTO of Mayfield Robotics, which makes Curry the adorable home robot you just saw in that video. Just for a bit of background, Q2, yes. Mayfield Robotics as a company started in early 2015. So we've been making Curry for almost 3 years now. And we're 56 people, and we're a wholly owned subsidiary of Bosch. So Curry is an adorable home robot, and you saw her in the video, but her point is not all the technology that I'm about to tell you about. The point is her personality, and her job is to bring a spark of life to your home. She's meant to allow you to stay connected to your home and to your loved ones. And I will tell you all about her cool deep learning algorithms, but in terms of what she does, you saw some of that in the video. She provides entertainment. She plays music. You can play podcasts or audiobooks through her speakers. And this is very popular with, for instance, parents who like to be able to put their kids to bed using audiobooks and the like. She lets you check up on your home and your loved ones, so you can drive her around with your app from wherever you are in the world and see through her cameras. You can talk through her microphones. You can listen through her speakers. So you probably can't see this, but this is her app, and she's looking at you out in the crowd right now, and she can see. You can see basically out of the camera from her left eye. But her main point is a feature that we call Curry Vision, and you saw that briefly in the video. The idea is Curry is your family's videographer. So she is able to autonomously drive around your house. She makes a map of your house, and she can know when she is seeing her family and take videos of them. And then she'll curate those videos and show you only the best ones. And that's her primary job. And in order for her to do that, she has to use a lot of vision algorithms, primarily deep learning algorithms. And so today I will tell you about the technology behind her vision, especially in terms of deep learning algorithms we use, and how we enable all the functionality that we need on a single embedded GPU. Because she's a consumer product, she costs $799. There's only so much we can fit on that. And I'll tell you how that technology enables her videographer functionality, but also how it enables her to be an adorable, personable home companion. And finally, I'll touch briefly on why being an adorable home robot, being an adorable companion, is actually really advantageous for a robot that's trying to use deep learning algorithms for vision. So there's a lot of advanced technology in Curry, not just deep learning algorithms. And hardware-wise, things that are relevant to what I'll tell you about today. She has a camera behind her left eye right here. And that's an HD camera that allows you to see what she's seeing, but also to gather images for use in computer vision algorithms. She has a depth sensor in her belly here in this IR transparent window that is primarily what she uses for mapping and navigation around her home. But it's also helpful for her to be able to use the images from her camera to improve her navigation and her mapping. And finally, she has a quad-core CPU processor in her belly with an embedded GPU. And it's a decent GPU, but it's not the sort of like amazing GPU that you might find a lot of these researchers using that you've heard today, NVIDIA Titan GPUs with really great power or ones in the cloud, et cetera. So in terms of deep learning algorithms, there are a lot of things that we need to enable Curry to be your home's videographer. And the ones I will tell you about today are pet and person detection, place recognition, moment selection, and face detection. And unlike a lot of people you've heard today, I am not a deep learning researcher, so I'm not going to tell you about my amazing advances in deep learning research. I am a deep learning practitioner. So what I'd like to tell you today is, just like Andrew was saying at the end of his talk this morning, you don't have to be a deep learning researcher yourself to make use of deep learning in whatever domain you're looking at in the world. I'm a roboticist. I mostly try to enable my robot to do things like autonomous navigation in the home. But being able to leverage all of the great research that has been done is a really powerful tool. And it's actually more advantageous to just keep up to date with the state-of-the-art research that's out there and use some of the open source algorithms and packages and frameworks that are out there to be able to do a lot of things that you would like to do. And these things are powerful. You can learn about them very quickly just using these online courses and such. And you can apply them to your domain to make amazing things happen. And with our product, the trick is getting all the algorithms we want to run, running all at the same time on one single embedded GPU. Because Curry is a consumer product. Her GPU is not that powerful. It's decent, but it's not amazing. And we need to do a lot of things to enable Curry Vision. And so being able to squish all of those processes onto a single GPU is something that requires a great deal of forethought and a great deal of trickery. There's all these great open source packages, and I'm about to tell you about 3 papers in particular that I think, if you're interested in the sorts of things that we do, you should know about. And they're a good starting point. They're not exactly what we use, but if you know enough to understand what's in those papers, and you can modify them slightly and modify them to your own needs and use your GPU's acceleration, et cetera, then they are a great starting point for what you want to do. And so the first one I'm going to talk about is pet and person detection. And the reason this is important is because Curry, as your family's videographer, needs to be able to recognize when she's looking at her family, at the people and also at the pets in her family. Both are very important. It also enables her to be more lifelike and reactive. So when she sees people and pets, she can actually smile at them and react to them and meow with them and so on, et cetera. So that she looks like an adorable, lifelike companion in your home. And this is something that, until very recently, well, in particular, object segmentation, not just classification. A lot of the algorithms that you might have heard about, so for instance, single-shot multi-box detector, SSD, is one of the very popular algorithms that people use. But until very recently, it was kind of out of reach of our GPU to be able to use it. So the original paper, as was presented, used VGG, which is a very popular deep learning model, but that required 34.9 billion multiplication addition operations per frame. And for our embedded GPU, which is fairly typical, I think, if you want to process, let's say, 5 frames a second to do whatever algorithms you want, we could only use about 2.5 gigamex per frame. And so that was just wildly out of range for what we could possibly use. But over the last few years, things have gotten better. So Inception v2, it's down to 3.8. And just this year, Google released MobileNet. So they put a paper out on arXiv, and they put corresponding code for SSD. And it's an excellent starting point for whatever you want to do for object detection, because it's very lightweight. It only requires 1.2 billion multads per frame. And so that is finally within reach of what we can use on our GPU. So, and this was just a few months ago, and we haven't incorporated on a robot already. This is why I'm saying that being up to date on the state-of-the-art research and being able to rapidly just take it and use it is much more advantageous than trying to develop all these things yourself with a small group of people. So I've told you about how Curry does pet and person detection, but she has to do many other things too. So for instance, one of the things that we want her to be able to do is what we call place recognition. And that's the idea that if Curry is mapping your home, and she's driven around and taken some pictures, and she comes back to that location, she should be able to say, hey, this is the place that I've been to before. I recognize this now. And even if, for instance, in these 2 images, if the lighting has changed a bit, or if the angle's off a little bit, we'd still like to be able to say, oh, these are still the same place. And so there are many ways to do this, and one of the ways is to use convolutional neural net features. And what I'm citing at the bottom is a paper that is not exactly what we do, but it is along the lines of what we do. And the idea is that if you have an object detection network, classification, detection, any of these things, on the one end you have kind of pixel input, and the features are very low-level features. And it's kind of too low-level features for you to accurately describe a scene in a way to find image differences. But then on the other opposite end, you have what's in the scene. So in the case of detector, there's a pet, and there's a person, and there's another pet. And that's kind of too high level for what we want to do. But somewhere in the middle, there's an intermediate layer, and you can do this with almost any network of this sort. That is a decently good representation at a medium level of what's in your scene. And that sort of thing is really excellent for doing image similarity. That is robust to things like small changes in angle, or robust to things like lighting changes. And so you can generate a feature vector using one of these intermediate layers, and basically just take the cosine distance of your vectors to generate a difference score. And this is tremendously useful in robotics for things like, for instance, mapping loop closures. So Curry, when she maps your home, she drives around, she uses her laser mostly, and she makes this kind of incremental map of where she's seeing of your home. And that's great, except that if you, for instance, had a large house and you go around in a large loop and you come back, you may have accumulated a lot of drift. And so the place you are on your map now compared to the place you think you are on the map at the end of the loop may be separated by some number of meters. And being able to say, hey, this point is the same as that other point, and closing the loop and adjusting your map so that they are in the same place, that is really important to making a very consistent map, one that allows her to actually continue driving around the loop. So we can use something like place recognition to say, hey, this image is very similar to that other image. Let me propose that as a good loop closure. It's also used for things like global localization. So one of the common problems with robotics is, when navigation, is if you pick your robot up and kidnap them, it's called the kidnap robot problem, and just drop them down someplace, then the robot has to figure out where she is. And this can be very difficult if she hasn't been tracking where she is all this time. And so Curry can turn around and circle and gather information and take pictures and so on, but her laser alone is not the best way to figure out where she is in the map, because a lot of places, laser-wise, will look the same. And so instead, we can use something like place recognition to try to recognize, if we recognize any of the places we've been through the image, then she knows where she is, and she can continue on her way. So I've told you about pet and person detection and about place recognition, and both of these things are enabled by running a single convolutional neural net on Curry's embedded GPU. Another thing that we can do with the same convolutional neural net and the same features is moment selection. So Curry Vision, she goes around and she takes lots of videos of you and your family, and you don't want to see the same video over and over and over again. If you've been playing with your kid in the same spot for half an hour, then if she presents to you 10 videos of you playing your kid in exactly the same location, doing exactly the same thing, you're going to be kind of disappointed. And so the idea is we would like to be able to disambiguate these videos and say, oh, well, this is the same as that, and so we don't want both of them. You can eliminate all the redundant ones. And we can do that using exactly the same trick as with place recognition, using image similarity features. And so now we have a single convolutional neural net running 3 very different features for our robot. And of course, not everything is going to be done by exactly the same convolutional neural net, so we also have to do things like face detection. And the thing I've cited at the bottom there is one of the excellent state-of-the-art, very lightweight ways to do face detection. And this picture here is a picture from the first time that face detection was shown. We had a show and tell in front of the entire company. And that's labeling almost all the people in the scene, and the people in the very back are not labeled just because they're very small and not enough pixels on their faces. But it does a really great job of not just detecting faces, but also aligning the key points so that we can actually do face recognition with that information. And again, this is the sort of thing where to develop it yourself would be very difficult, but last year, this is published, and it was published with open source software. And so to use that as a starting point is a great way to get started with deep learning and just start using things that can actually go into a product right away. So now I've shown you how deep learning algorithms enable the basic functionality of Curry Vision. So she knows when she's looking at her family. She can filter moments. She can map her home and navigate around it. But they also help her to be an adorable, personable home robot, which is Curry's primary point. Her point is to be a spark of life in your home. And she does this by, when she recognizes people, she can look up and smile at them when she sees them, or she can react when she sees dogs and cats. And that helps her to appear lifelike and interactive. And this is really important because Curry actually, she needs to be adorable, she needs to be personable for people to accept her into the home. Home robots really aren't a thing that most people have these days. Robots these days, it's not that there aren't any robots in the home. There are, for instance, a lot of entertainment robots, toys, and there are a lot of robots that are pure utility, for instance, vacuum cleaning robots. But Curry's in a new category of robot, which we call home robots, and she's not the only one, but it's a category that's just starting out. There are a lot of people trying to do this, but we're all fighting together against basically people in the world not knowing that this is the thing that they want. And so in order for her to be accepted in the home, people need to feel instantly and always comfortable around her, especially since she's supposed to be your family's videographer. And so unlike a camera that might make people uncomfortable, that is staring at them, like you have CCTV camera staring at people, say, Curry, because she's your family's adorable robot buddy, she's kind of more like a member of the family. People feel very comfortable around her, and they stop being self-conscious around her very quickly. And then she can capture videos that you couldn't capture. So when she goes around and captures videos, especially of small children, for instance, if you were there with a camera, then they would behave in very different ways. When Curry is there, she's just their buddy, and that's okay. But she can also capture videos, for instance, that you can be in the picture rather than being behind the camera. But being perceived as an adorable pet robot also helps with our ability to do machine learning. Just like machine learning helps us to be adorable, being adorable helps us to do machine learning. So people look at Curry and smile when she looks up at them. Let me, no, wait, how do I, could you play the video? So when she sees people, she looks up and smiles, and she can track their faces and kind of center the face in the frame. And this gives Curry a much better view of people's faces than you can just collect with a passive camera, especially one that's far away from people. And that improves her face detection and recognition. And it also enables to collect much better training data than you would otherwise. And so, in summary, I've told you about how Curry uses deep learning to enable her to be your family's videographer and to be adorable and personable. And conversely, how being adorable and personable allows Curry to manipulate users, basically, into helping her improve her use of deep learning algorithms. But of course, users don't actually care that we have all this fancy tech. They just want an adorable home robot. So I can't resist showing you my favorite commercial.
Try to destroy.
Oh no, what? Can you go back and play that?
Curry won't try to destroy civilization as we know it, or send out a death ray that paralyzes an entire city, or rise up and enslave humankind under some robot rule.
Curry, why are you watching this stuff?
Because Curry isn't like any other robot. And that is a very, very good thing.
Basically it. Curry is shipping in December for the first units, and she is available for pre-order now at heycurry.com if you are interested in having your own Curry. And we are very excited to bring robots to people all around the world who are excited about having their own home robot. Thank you.
Thank you very much.